Hey guys, Chris here. I'm recording a quick solution to our number 28, which is talking about if a monopolist enjoys limited market power, does that increase or decrease their expected profit, right? Compared to if they had a normal amount of market power, maybe a lot of market power, right? So in order to really answer this question, we're going to have to draw a monopolist kind of with a normal amount of market power, right? And then take some of that market power away. How would that change the graph? And we'll calculate the new profit as a result, okay? So first of all, let's go ahead and let's graph the normal cost curves of the monopolist, right? Right, and so for this one, we can have little q or big Q, right? Because the monopolist is the market by definition, okay? And so we're gonna have some average total cost curve going like this. We're gonna have average variable costs going like that. Then let's see here, we've got a marginal cost curve up there. And the thing that changes here is the fact that we have, instead of a flat line, right, instead of a horizontal line that is just the price, right, and then the marginal revenues, however many they sell at that price, now we have a situation where if they lower the price, they'll sell more, right? So that's a situation, you know, that's typical of demand, right? And that's why we end up with a demand curve here on this monopolist graph here, right? So this is a monopoly, right? This could be, you know, Comcast or something like that in your town, right? Could be the water company, the electric company, those kind of things, right? So we have a demand curve, and then we have a marginal revenue curve that has twice the slope as the demand curve, okay? From here on out, though, the same rules apply in terms of we're going to produce at that point where the marginal revenue is equal to the marginal cost, right? Now, here's where things get a little different. So whenever we find that point where the marginal revenue is equal to the marginal cost, we drop down that anchor, right? And that's going to be our equilibrium quantity. That's how many the monopolist is going to want to produce to maximize their profits, not equilibrium quantity, maximizing quantity here. But it gets a little tricky in terms of how much do we charge for the product if we're the monopolist, right? You know, a lot of you, I think, are tempted to put a line from this point out to here, right? But that's wrong, okay? This price that's associated with that has absolutely nothing to do with our problems or with the monopolist decision or anything like that, right? And that's because of the fact that the monopolist can and will charge everything they can for this, right? And how much can they charge? Well, that's what the demand schedule tells us by definition, right? The demand schedule tells us how many units will be sold at different prices. So at this price, or sorry, at this quantity, the profit maximizing quantity, what price are they going to choose? They're going to choose the price that, you guessed it, is the price that's going to sell that many, right? They don't want to just produce all these and then not have them sell. And so this is going to be our equilibrium price, right? So our P star is going to be a reflection off of the demand curve and not of the marginal cost curve, right? Or the marginal revenue curve, which is what it was before. It was off the marginal revenue curve in the perfectly competitive world. So now if we wanted to look at the profits here, it's the same kind of deal in terms of, you know, we just find, you know, if this is the total revenue, right? If total revenue is this big, huge guy, now why is it this big, huge block here? Well, because what's total revenue? Total revenue is just price times quantity, right? I guess we should not do the star, but do the X because that's P star. So it's just price times quantity. So if this is the price, if that's the quantity, multiplying together gives us a rectangle, right? So this area is the total revenue. In order to get the profit is just what? Total revenue minus total costs. So we need to take away those total costs. Well, how do we get those total costs? The total costs we're going to get by multiplying the average total cost curve by that quantity, right? So that's why when we deal with the profit square, we always kind of stop at the average total cost curve, right? The reason why we're doing that is because this region here, this is the total cost, right? This area is the total cost. So really, you know, we're kind of subtracting that away from the total revenue in order to get this profit. split. All right, so the monopolist is, they're sitting pretty, on this profit square with this regular amount of market power. And now, since this is a bit crowded, let's go ahead and to the left of this, let's go ahead and graph what happens if that monopolist did not have as much market power, okay, if they had limited market power. Or, honestly, it's just, let's say it's a more elastic market, right? That would be a better prompt, I apologize, than having less market power, right? So if it's a more elastic market, what's that going to do? That's going to make this situation look a bit more like a perfectly competitive situation, right? So instead of having a demand curve that slopes down with, this is probably a slope of negative 1, right? In terms of for every run, there's a fall of 1, right? So it's a slope of -1 here. So instead of having it be a slope of -1, let's say it's a slope of 0.25, right? Let's be drastic here in terms of the change, right? So if it's, let's kind of put this a little bit so that we don't have to change things up too crazy. So the slope of 0.25 would be something like that, right? For every 1 run, there'd be only a quarter of a step, right? So very, very shallow steps here compared to normal steps over there. And then everything else is going to be the same, right? And then remember, the marginal revenue curve is just twice the slope of that. So if this is 0.25, the marginal revenue curve will have a slope of 0.5 or something like that, right? Which probably is a bit steeper than that. Yeah, that is marginal revenue and demand. So let's go ahead and we'll try and do the same kind of cost curves. I'll do them in a different color for us so that you don't get as confused. All right, let's go ahead and like that. Something like that, right? This is our ATC. This is our ABC. This is going to be the marginal cost, right? So again, profit maximizing decision. We choose the quantity that we're going to produce according to where the marginal revenue intersects the marginal cost. Okay, so that's going to be the Q star. And then how much profit or loss are we making here? Well, we might get tricked again, right? Could happen, into thinking that this is how much we're going to be charging, right? But remember, in a monopoly example, this quantity here, right? Like you guys are going to be tempted, I know I am, to write out that is some important price, right? But it never comes into play. Okay, so I want you guys to try and if that happens, a big red flag, red siren should go off in your mind, right? That's not actually anything, okay? Because at this quantity, the monopolists are going to charge everything they can charge, right? So they're going to charge all the way up here on the demand curve, right? So this is going to be P star. That's going to be the price that they're charging now. And now we can see very clearly what happens to the profit, right? So we'll do the same steps as before. If we calculate the total revenue, it's this big triangle here, right? Just the price times the quantity. If we calculate, if we take away the costs, right? I removed the formula, but total cost is just equal to average total costs times quantity, right? So we're going to find that quantity we're producing. Where does that line intersect the average total cost? Right here. We're going to draw a dashed line over. That's going to be the lower part of our profit square and the upper part of our total costs, right? So now if we were to segment out those total costs, it'd be this whole thing, right? And that's because of the fact that this amount here is our average total cost. So at the end of the day, we used to have this big profit square that big, right? And as a result of the decrease in the market power, or you could say as a result of the more elastic demand curve than we previously thought, they're still going to be enjoying some profit, right? There's still going to be some profit, but the profit that they're enjoying is going to be less, right? So this is our new profit square, right? And it's very easy to see that the new profit square is going to be much smaller than the old profit square, okay? So being able to show this either in two separate graphs or on the same graph is important and may be on the test. So please let me know if you have any questions about how to do that, and I'll be sure to clarify them over email or in office hours tomorrow from 9 to 4.